This is section 5.4. It's all about rational expressions. So the first thing we need to do is to actually just define what is a rational expression. And basically, rational expression is a fractional expression. Okay, basically it's a fraction. But you might be saying, well, why do we need another name for a fraction? Well, when we say a fraction, it's not like the old days basic fraction like 24 over 9 or 8 over 3. That's a fraction. But we don't really call it rational because it doesn't have any variables involved. So it's a fractional expression that usually has variables. So like if you look down at this next row, all of these would be rational expressions because they all have x's and y's in either the numerator or denominator or even both. It doesn't matter where, as long as it's somewhere in the fraction. Okay, so we need to talk about how do we simplify rational expressions. And this is probably one of those common mistakes that so many algebra students make, is that they don't know how to simplify correctly. They assume that they do. They assume that it's okay to cancel anything, and it's just not okay. Okay, so first of all, we're going to go way back to when you first learned about simplifying fractions. And even though you probably don't think through these steps right now, I want to show you the why behind simplifying fractions. So if I want to simplify 24 over 9, the way you would have been taught to do this is to say, well, what's going to multiply to be 24? And you can pick anything you want, but let's just pretend, let's say we decide to pick 8 times 3 for 24. And then what's being multiplied to equal 9? Let's say we pick 3 times 3. And then you learned that, so 8 and 3 are both factors because they're being multiplied, and the 3 and 3 are both factors because they're being multiplied. So because everything's being multiplied, it's okay to cancel the factor of 3 on top with the factor of 3 on bottom. And that's why your simplified fraction would be 8 over 3. Okay, that's not true if you had an addition problem. So if you had, for example, 8 plus 3 over 3 plus 3, these are not factors because they're not being multiplied. They're called terms. If they're being added or subtracted, then it's called terms. So it's not okay, so put your pencil down and don't do this. It's not okay to cancel those 3's in that situation and say the answer is 8 over 3. It's not okay, because if you did that, you'd be saying, I mean, if you didn't cancel, 8 plus 3 is 11, 3 plus 3 is 6. If you said that was okay, you'd be saying that 8 over 3 is equivalent to 11 over 6, and it's just not. Okay, so I don't want to get rid of this. I want to get rid of this because I don't want you to see it there and think it's okay. So when we look down here at these examples, do you see that in the first example, it is okay to cancel this 3 with this 3 because those 3's are factors, because the 3 is being multiplied by the x plus 1. This 3 is being multiplied by the y plus 2. So it's okay to cancel the 3's and just have x plus 1 over y minus 2. That's fine to do that. But look at the next one. It's not okay to cancel these 3's because they are terms. They're not factors. They're not being multiplied by x or multiplied by y. They're just being added. So you might say, well, if I can't cancel them, what do I do? And the answer is nothing. You can't do anything to that. You would just leave it. Okay? Look at the next example. Now, put your pencil down. Don't write. I want to tell you, this is probably what I see all the time. And even though we're going through all of this, and we're going to spend a ton of time doing these, and we're going to do homework, we're going to practice, then when we get, in a couple weeks, if I were to give you this problem, somebody is going to go in and do this bad thing. So put your pencil down. Don't write. Just watch. Somebody's going to look at this next problem, and they're going to say, oh, hey, look, I'll cancel those x's, and I'll cancel those 1's, and I'll cancel those x's, and then my answer is just 2/3. And that is absolutely not okay. It is not correct, because when I did that, let me go back to the very first thing I canceled. By doing those x's, you were canceling terms because that x is a part of the plus 1. Now, this parenthesis x plus 1 is a factor, and this parenthesis x plus 2 is a factor, and it's okay to cancel the entire factor, but it's not okay to just cancel one of the terms in the factor. So it was okay to cancel that x plus 1 factor with that x plus 1 factor, and then be left with x plus 2 over x plus 3. That's okay. Look over at the next one. Again, the most common mistake, people are going to say, okay, great, I'll cancel the entire factor. But you can't do that because that on the top, this is a term because of that plus sign. So you can't do anything to that one. Okay, all of that to say, here's what we're trying to make the point of. Never, never, never cancel terms. Meaning if it's a part of addition or subtraction, if it's just part of an addition or subtraction, not the whole thing, you can't cancel it. You can only cancel factors. Remember, factors are something that's being multiplied. You can only cancel factors. So when I look at number 1, we've actually done these way back first semester. We never talked about, we never made a big deal about the fact that they were all being multiplied. So when I look at number 1, the 3 is being multiplied by the x squared, which is being multiplied by the y. So the entire numerator is being multiplied. The entire denominator is being multiplied. So it's okay to cancel them separately. It's okay to think about the 3 and the 12 and cancel, or to think about the x squared and the x and cancel. So when I do this problem, it's okay to say, hey, look, that 3 goes into 12 4 times. All right, so if I do that, that means the 4 is on the bottom. And there's nothing of that 3 left. You might say there's a 1, but otherwise there's nothing of that 3 left, right? Okay, let's go over to the x's. It's okay to look at the x's separately and say, hey, look, that x squared and that x is going to cancel and just leave a single x on the top. That's okay, because the x's are being multiplied by everything else. Similarly, it's okay to say that that y can cancel with the y squared and leave a y on the bottom. So there's my simplified answer. I'm going to come back to number 2 in a minute. I'm going to go over to number 3. But it's not okay to go in and say you can cancel those p squareds. Why? Because it's a part of addition. You see the plus sign right there? That means it's a part of a term, not a factor. So in this case, you're saying, well, how do I cancel? And as it is, you can't. Go back to number 2. As it is, you can't cancel. So then what is this section about? Well, how do you simplify rational expressions? And that is, we're going to write this down, step 1, factor numerator and denominator. You have to factor the numerator and the denominator. So on the top, if I factor, let's see, I can take out a common factor of 3. That's going to leave me with 2 minus k. On the bottom, when I factor, that's a difference of squares, but it's going to be k plus 2 and k minus 2, right? Okay. So now, can I cancel any factors? And, is k minus 2, so the question here is this, is k minus 2 the same as 2 minus k? Because if they're the same, it's okay to cancel. I'm not canceling separately the k's and then the 2's. I'm canceling the entire parenthesis. So are they the same or are they different? Well, that's like saying, let's say, what if k is 3? Okay, if k is 3, then that's like saying, is 2 minus 3 the same as 3 minus 2? Well, 2 minus 3 is negative 1. 3 minus 2 is positive 1. So are they the same? Well, they're the same number. They're just negative of each other. Okay, so let's go a step further. How would I simplify negative 1 over 1? Well, doesn't that just equal negative 1? So all that to say, it's okay to cancel these, but you're going to leave a negative 1 in place of one of them. It's like canceling a 3 and a negative 3. It's okay to cancel, but you're going to leave a negative 1. So what I actually have here on top is I have negative 3, and on the bottom I have k plus 2. So that's my simplified answer. Okay, let's go to number 3. Before I can start canceling, because they're all terms, I need to factor. So I'm going to turn them into factors. So on the top, I'm going to do trial and error. Let's see, I need a plus and a minus. And on bottom, for the 4, I can't do 2 and 2, right, because of the other 2 that's there. So I'm going to have to do a 4 and 1. So 4 and 1. So is that going to work? Well, actually, I have a problem. Isn't that going to give me a negative 7 in the middle, right, if I do my outer and inner? So I think I need to make this be a plus and make this one be a minus. that's going to work now, right? I'll have a positive 7 in the middle. Okay, so I factored the numerator. Let's factor the denominator. How about if I do a common factor of 5p? So that's going to leave me with p plus 4. Okay, so now do you see I can cancel this entire factor with this entire factor. I cannot cancel those p's because they are part of the terms, so I'm just going to be left with 2p minus 1 all over 5p. Okay? So, what if I have fractions that I'm multiplying? Well, that doesn't change anything. If they're being multiplied, just think of this as one big giant fraction. Since they're all being multiplied, I can just go in there and just start slashing away, right? 7 goes into 14 2 times. 5 goes into 15 3 times. And then if I have a squared over a, doesn't that just leave me with a single a on the top? So I'm going to have 3a over 2. Okay, so on number 5, yeah, there's multiplication in the middle. So yes, I can think of it as one big giant fraction, but you got to keep in mind, this is a subtraction problem. This is an addition problem. So it's kind of like, yes, I have factors on the top, but inside the factor, it's addition and subtraction. So again, I still need to go in and factor everything. So let's start with this one here. I'm going to say common factor of 5. It's going to leave me with x minus 3. Okay, let's go to this parenthesis. Common factor of 4 leaves me with x plus 3. Yeah, I know you can hear the dogs. So I'm going to go to this one right here. Common factor of 3 leaves me with x plus 3. And then this one right here, common factor of 2, I'm thinking, leaves me with 3x minus, oh, I could have taken out a 6. Let me back up and do that. Right? If I take a common factor of 6, leaves me with x minus 3. Okay, so now can I cancel any factors? Well, this x plus 3 factor cancels this x plus 3. Notice I didn't cancel the x's and then separately the 3's. I didn't cancel terms. I canceled the entire parenthesis factor. I can cancel this entire factor with this one. And then on top, I have the 5 times 4, which is 20. And on bottom, I was just looking to see if I could have canceled. Oh, I could have canceled some, but you know what? I think I will. Do you see that I could actually cancel the 4 and the 6? Because doesn't 2 go into 4 2 times and 2 into 6 3 times? So what I actually have on top is 5 times 2 is 10. And the bottom, 3 times 3 is 9. Okay, so man, this section is all about factoring. All right, so because it's multiplication, I'm going to think of it as one big giant fraction, but I'm still going to go in and factor everything. So for that first piece, I'll say x plus 5, x minus 5, right? Because it was a difference of squares. I can't do much with that 10, so I'm just going to leave that 10 on top. On the bottom, for the 2x plus 10, I can do common factor of 2. Leaves me with x plus 5. And then this 5 minus x, I can't factor it, so I'm just going to leave it as a 5 minus x. Okay, so when I go in and start canceling, the entire x plus 5 factor cancels. And do you remember what we said, x minus 5 and 5 minus x? Remember we said they're the same, except it leaves a negative 1. Okay, so I can still keep canceling. Can't I cancel the 2 and the 10? 2 goes into 10 5 times. So on top, remember, this is all being multiplied. So it's not negative 1 plus 5, but it's being multiplied. So it's negative 1 times 5. And since there's nothing left on the bottom, it's kind of like having a 1 on the bottom. So my answer is just 5. Okay. All right, what if I'm dividing fractions? Well, nothing changes in that you still have to factor everything. But think about when you divide fractions. Like if I just said, hey, what is 2/3 divided by, I don't know, I'll say 5 over 7. Didn't you learn that on division you have to do like keep, change, flip? So like you would keep the 2/3, but you would change the division into multiplication, and then you would flip the second fraction. So basically, we're going to change these into multiplication problems. So I'm going to think of this as 2 minus t over 8 times, flip over the second fraction, 6 over t minus 2. Okay, so you have to think of this as a parenthesis factor. So in this case, I can cancel, let's see, 2 goes into both 6 and 8, right? 3 and 4. And I can cancel 2 minus t with a t minus 2. It just leaves a negative 1. And it doesn't matter where you leave the negative 1, on top or bottom, it doesn't matter. So what I end up with on top is just 3. On the bottom, this is not 4 minus 1, it's 4 times negative 1, so negative 4. Okay? So on number 8, yes, we're going to factor everything, and as a part of it, we're going to flip the second fraction. All right, so let's work on this first fraction. Here's the one I'm working on right now. So I'm going to think trial and error. Got to have different signs. 2x and x. The only way to get that 1 is 1 times 1. Is that going to give me a negative 1 in the middle? Yep, it is, right? Negative 2, positive 1. That's going to work. Okay, let's go to the bottom. Trial and error. Both pluses. So 2x times x. The only way to get 3 is going to be 3 times 1. Why don't we go 3 and 1? Is that going to give me a positive 5? Yep, 3x and 2x gives me positive 5, so that works. Okay, so I'm going to change it into multiplication. I'm going to work on this one, but I'm going to put it on the top, right, because of the keep, change, flip. So for that, I'm going to do my trial and error, different signs, 2x and x. Got to get 3 and 1. I'm going to go 3 and 1. Now, do you see that this is going to be, if I do outer and inner, negative 6 and 1 is negative 5. That's not what I want, right? So I'm going to switch the 3 and 1. I'm going to switch the 3 and 1. That's going to give me positive 3 and negative 2. That's going to work, okay? On the bottom, so I'm working on the 4x squared minus 1. Isn't that a difference of squares? 2x plus 1 and 2x minus 1. Okay, so because it's multiplication, I'm just thinking of this as one big giant fraction. All right, can I cancel factors? Let's see. 2x plus 1 cancels 2x plus 1. 2x plus 3, 2x plus 3, but nothing else, right? Both of these x minus 1s are on top, so they can't cancel. X minus 1 can't cancel x plus 1, so that's all I can cancel. So you just leave on top x minus 1, x minus 1, and on bottom you would leave x plus 1 and 2x minus 1. And that's perfectly fine. Still is more simplified than what we had up here for our original. Okay. Really, number 9 is going to be the same as number 8, where you're going to go in and factor all 4 of those, flip over the second fraction. So that's going to be just like number 8. So let's go to the next type. We're going to simplify these complex fractions. Notice you have a fraction over a fraction. And so what you have to do is you have to think of it as this fraction, 10 over x minus 3, is being divided by that bottom fraction. And so if you look at it that way, it's just like what we did in the previous page, right? Where you do kind of the keep, change, flip thing. Oh, what happened? I don't know what just happened here. Okay, so we can do that. So now I would factor everything. Let's see. The 10, nothing I can do there. The x minus 3, nothing I can do there. So now I'm going to change it to multiplication and flip it. But for the 2x minus 6, I'm going to take out a common factor of 2. So, and I'm flipping this over, so the 5 is going to go to the bottom. So now because it's multiplication, I'm just thinking of this as one big giant fraction. So in this case, because this x minus 3 is separate from the 5, I'm thinking of it as its own parenthesis. So the x minus 3 factors can cancel. And let's see, 5 goes into 10 2 times. So it looks like all I'm going to have on top is the 2 times 2 is 4. Okay. So this is the same scenario, but I like to kind of first of all take it out of that fraction within a fraction thing. So what I really have here is I have the x squared minus 100 is over x minus 3. That's being divided by the 10 minus x over all of that, x squared plus 7x minus 21. So now I can factor everything and do my keep, change, flip. All right, so for the first numerator, difference of squares. Okay, can't do anything to that x minus 3. That can't be factored. So I'm going to change it to multiplication. I'm going to work on this because I'm flipping it over. So trial and error. So I need a plus and a minus, x, and x. And actually on this one, I don't think this is going to factor. I mean, I could try 7 and 3. That's not going to work. I could try 21 and 1. That's not going to work. So here's a situation where it just didn't factor. Okay. So I'm just going to leave it. Probably made a mistake, but when I wrote it down, but that doesn't matter. So I'll just leave it as, so it's like one big giant parenthesis of x squared plus 7x minus 21 over 10 minus x. Can't do anything to that. Okay, so can I simplify? Well, let's see. I can, the 10 minus x and the x minus 10, that's going to cancel and leave a negative 1, right? And I think that's all I can cancel. So on top, I have negative 1. That's being multiplied by x plus 10. It's also being multiplied by x squared plus 7x minus 21. And on the bottom, I have x minus 3. So it didn't simplify that much, but too bad. There's my answer.